Lesson 2-9, Nonlinear Inequalities. We're looking at how to solve nonlinear inequalities. And so the steps are, you start by making one side a 0. And then you find all the critical numbers, which are the zeros of the function and the places where it's undefined. Plot all those on a number line, and then you're going to pick test points and test them. So it'll divide the number line up into little sections. You're going to pick a test point from each section. All right, so this is a quadratic inequality. So we're going to start by finding the critical number. So one side is already equal to 0. So we're going to find the zeros. Maybe we could do it by factoring. I'm going to have it equal to 0 because that's how you find the zeros, is they're equal to 0. Let's see, I think it's probably going to be minus 6 and plus 1. So then you take each of those equal to 0. So x is 6 and x is negative 1. So those are my critical numbers. There's no places where it's undefined. So I have a number line. It's less than but not equal to, so these are going to be open circles. If it can be equal to that number, it would be a closed circle. If it's can't be equal to, such as in this case, it's open circles. And notice now we have 3 parts. We have less than negative 1, we have between negative 1 and 6, and we have greater than 6. So I'm going to pick a test number from each of those spots, such as negative 2. So we plug that into the original inequality and see if it's true. So 4 plus 10 is 14, minus 6 is 8, is less than 0. No. Let's try testing something in between negative 1 and 6. 0 is between negative 1 and 6. Plug that into the original inequality, and I get negative 6 is less than 0. That's true. So I'm going to go ahead and draw the line there where it's true. And something bigger than 6, like a 7. So it'd be 49 minus 35 minus 6 is 8, is less than 0. No, that's false. So it looks like the answer is the places in between. So it is between negative 1 and 6, or in interval notation, negative 1 to 6, parentheses because it's not equal to. There is another way. Instead of doing test points, you can superimpose a graph. So this was quadratic. The leading coefficient was a positive 1, so it opens up. So I know that it would be a parabola that comes down like that. We want it to be less than 0, so it would be all the x values where my graph is lower than my number line, lower than the x-axis, because think of it as a xy plane. So it's between the negative 1 and the 6. All right, let's try this one. This one does not have a 0 on one side, so let's add 16 so that I end up with 0 on one side. So we'll add the 16, so I have 0. Well, we could do p's and q's, or it's 4 terms. Maybe we can factor by grouping. If I do that, remember to leave the negative with the 12, with a plus in between. It's always going to be a plus in between their groups. First group, I can factor out an x squared. leaving 3x minus 4. The second group, I can factor out a negative 4, leaving 3x minus 4. Hey, this looks good. So now those are the same. I can factor out the 3x minus 4, leaving x squared minus 4. Oh, but the x squared minus 4, that's a difference of squares. So it would be x minus 2, x plus 2. Actually, these should all be equals because I'm finding my zeros. So now I take each of those equal to 0. So I get x is 4/3, x is 2, and x is negative 2. Put that on a number line. Here's negative 2, 0, positive 2, 4/3 is 1 1/3, so that's right there. Now, again, this is not equal to, so they are all open circles. And then we have to pick test points. So a test point less than negative 2 is negative 3. Between negative 2 and 4/3 is 0. Between 4/3 and 2, let's see, we could maybe pick 1 1/2. And then greater than 2 is we could pick 3. So if I test negative 3, plug it into the original. Oops. Let's see what we get. 3 times negative 3 cubed minus 4 times negative 3 squared minus 12 times negative 3 is negative 81 is greater than negative 16. No, that's not true. All right, let's try the 0. Plug the 0 in for the x in the original function and original inequality. And I get 0 is greater than negative 16. That is true. So the section that has the 0, that's part of my solution. All right, let's try 1.5 or 3/2. Okay, put it in the calculator. And I got negative 16.875 is greater than negative 16. No, that's not true. All right, something bigger than 2, we said we're going to try a 3. Plug the 3 into the original inequality. And let's see what we get. I get 9 is greater than negative 16. Yes, that is true. So that area. So my answer appears to be from negative 2 to 4/3 and greater than 2. Or negative 2 to 4/3 combined with 2 through infinity. Another way you could do this is a cubic function. We know the general shape of a cubic function goes like that with the leading coefficient positive. So we know it goes up, come down through the zeros, and then go back up. We want this to be greater than 0, so we want the places where the graph was above the number line, which are the areas that we chose. That's just a shortcut. Last example for today is this one. It's a nice rational inequality. Well, we need to start by making it 0 on the one side, so we'll subtract the 1. Now to combine these, though, I need a common denominator, so it'll be x minus 3 over x minus 3 instead of our 1. Then combine like terms. On the top, I'll have 2x, and remember it's minus a negative 3. Negative 5 minus negative 3 is negative 2. And the common denominator. All right, so our critical numbers. Let's start with finding the zeros. That would be when the top equals 0. So that's x is 1. If I put that on our number line, now it could be equal to. So the zeros, it could work, could be equal to. So I'll make that a filled in dot. And then the undefined areas. It'll be undefined when we're dividing by 0, so when the denominator equals 0 at 3. So we are undefined at 3. It can never be equal to an undefined, so it'll always be open. So that's my two critical numbers, the zeros, the top equals 0, top of the fraction equals 0, and undefined when the denominator of the fraction equals 0. And now some test points, maybe a 0, and 2, and 4. Start with 0. 3 times 0. Just go ahead and plug it into the original. So that'd be negative 5 over negative 3, or 5/3 is less than or equal to 1. No. That's 1 and 1, 1 and 2/3. Let's try the 2. So that would be 1 over negative 1, or negative 1 is less than 1. That is true, so this middle section works. Students usually ask, does it always go every other one? No. So that's why you have to check everything. All right, trying the 4. All of 12 minus 5 is 7 over 1. Is 7 less than 1? No. So it looks like my answer goes from 1 to 3. It includes the 1, so the 1 would be the square bracket, the 3 would be a parenthesis. Or if you'd like, 1 is less than or equal to x is less than 3.